Bismillahirrahmanirrahim. Assalamualaikum and a very good day. I bid to Dr. Faisal and my fellow friends. My name is FARAH ZULAIKHA BINTI JAFRIKHAIRI, matrix number 207785 from Bachelor of Aerospace Engineering. Today, I'm going to present my mini project on the simple catapult system. Basically, catapult is a ballistic device used to launch a payload without the aid of gunpowder. A catapult works by the mechanism of a sudden release of stored potential energy to propel its payload. The first one is onager. Onager catapults initially launch projectiles from a sling. To fire an onager, the arm was forced down against the tension of twisted ropes or spring by using a windlass before it is released to launch the payload. Okay, the next one is ballista. Ballista was an ancient missile weapon that launched either bolts or stones at a distant target. Ballista were accurate but lack of firepower compared to mangonel or trebuchet. And the last one is mangonel. This machine was designed to throw heavy projectiles. Mangonels were mostly used for firing various missiles at fortresses, castles, and cities. These three medieval weapons have a commonality in which each one of them works by implementing the law of conservation of energy and also the knowledge of the motion of a projectile. A simple catapult system illustrates the law of conservation of energy, as the energy created in the system is neither created or destroyed. As the catapult is bent downwards, the rubber band stretches, creating a tension which is stored as an elastic potential energy. As the catapult is launched, elastic potential energy stored in the rubber band will be converted into the kinetic energy. From the previous diagram, we can express the equation using the principle of conservation of energy. From this equation, we can find the initial velocity as below. In this calculation, we will ignore the gravitational pull acted on the object. The diagram shows the projectile motion of the object when the catapult is released. Note that in this project that the air resistance is ignored and the initial velocity of the object is kept as constant. To study the relationship between the launch angle and the range of object projected, the launching angle is manipulated at the various range of launching angle as what had been shown in Table 1. The value of range is calculated using the equation where r is equal to v squared sine 2 theta divided by the gravity. From this graph, we can see that the range of the object projected increases as the launching angle increases. However, when the launching angle is greater than 45 degrees, the range of object projected will decrease gradually. This is because at an angle greater than 45 degrees, the time for the object to travel horizontally increases, causing a greater range of distance travel in the vertical component. So, what we can conclude here, the angle of 45 degrees is the optimal angle to reach the maximum range of the projectile motion. As a conclusion, we can say that there is no energy loss or destroyed in the catapult system. However, the energy is converted from one form of energy to another. From this study, we can also conclude that the angle of 45 degrees is the optimal angle to reach the maximum range of the projectile motion. This is because at this angle, both of the horizontal and vertical velocity of the object are maximized. So what I can learn from this mini project is I can apply the knowledge that I have learned in class in a completely broader perspective. I also enjoyed the process of completing this report as I can gain new knowledge and experiencing it by myself. That's all for me. Thank you.